Welcome back, Math 152 students. Sorry about that abrupt cutoff. We were looking at the y-intercept and had established that we needed to look at the x value and the y value. So when we have our x value with units and our y value with units, we want to pair those together and write a sentence. We could say something like, a bear with a length of 0 centimeters has a predicted weight of negative 142.471 kilograms. Something like this. But as soon as I write that, or maybe even as soon as you had this negative weight here, you might have realized you had a problem. This doesn't make sense. So a lot of times my math lab might say something like, this y-intercept cannot be interpreted, or it has no meaningful interpretation. You could also say an x value of 0 is out of the scope of the model. But I want you to start by trying to write this sentence even if it feels like nonsense. Part of the reason is then you have to go on and identify why it doesn't make sense, or it's helpful if you can identify why. So part of the reason is a length of 0 centimeters is not a reasonable length for a bear, even when they're first born. And you can't have a negative weight. So to try to understand what's going on in this problem, let's go back to our StatCrunch. And part of the issue is StatCrunch chooses how to format the x-axis and the range of values it uses there. So notice I start slightly below the x value of that first data point with the lowest x value. So it looks like my smallest length is a little bit above 120 centimeters, nowhere near 0. One thing you can do is double click on the x-axis, and sometimes it's a little tricky. So let me go back here. If it's not working to click on the axis, I was hovering right over my total length. And notice it gives you an option that you can edit this x-axis. I'm just going to back it all the way back up to 0. Notice what's happening here. Things got funky, but notice they also dropped below. In other words, it looks like I would need to modify my y-axis as well. There we go. So that time I was able to kind of double click on the axis and not the weight. And let's say I wanted to make that go to 0. See if that looks any better. So still, we're not quite capturing what's going on here. In other words, at some point, I'm going to have negative weights if I track my prediction line back. I'm just going to change that one more time. And I'm using negative 150 simply because my y-intercept was close to that. So I don't love how this looks in StatCrunch either, because you sort of miss the x-axis coming along here. But what it's showing you is this value of 0 is a huge extrapolation. Part of the reason it doesn't work very well is you have a data value that's way outside the scope of your model. And in fact, I think I like having it at 0 a little bit better, because then you can kind of see, oh, if you kept on tracing it back, you have big problems. And sort of the place at which your model breaks down is kind of right in here. When you start predicting negative values, you know you have a problem. So one last thing you might see in my math lab is something to the effect of, this is beyond the scope of the model. You're extrapolating too far. So we're using extrapolation to refer to predicting values that are outside the range of the model. So anything out here is an extrapolation, or if you had x values that were really large, but anything where you're using an x value that's inside the scope of your model, think about it kind of inside the bounds of the plots, is an interpolation. So let's go back and look at the last part for us to answer. We want to look at predicting and then residuals. So for part C, we're looking at a 149 centimeter bear. If we want to predict the weight of the bear, we just need to plug into our regression line. I would recommend writing down your calculations before you put them into the calculator, just to make sure you're clear on what you're doing, and also so that if you're using the Ask My Instructor, you're showing me what numbers you used. If you rounded to 2 decimal places and did the correct calculation, because of rounding error, your answer might be counted wrong. So make sure you're really clear on how many decimal places and what you're putting in, so if you run into issues, you can write down that work, especially for things like the midterm. So if you do this computation, you're getting 109.935. So keep in mind, you have units of kilograms, and let's think about what this is saying. If I have a bear that is 149 centimeters, I'm predicting that it will be approximately 110 kilograms, or if they want more decimals, we could give 109.935. So for the residual is always actual minus predicted. So this value that we just calculated was a prediction. The actual value is the value collected and displayed in the data table. So notice we actually have, or should have, if we're going to do a residual, a bear that's 149 centimeters. So notice the bear that's 149 centimeters was actually 85 kilograms. So in this case, my residual is 85 minus that 109.935. And computing that, I'm getting negative 24.935. Your positive and negatives do matter in this case, so be careful about your order of subtraction. If I'm thinking about what this is telling me, it's really telling me that this bear is below average. As long as I know it's negative, below average weight, and this bear in my data table is 25 pounds approximately below what we would have predicted. So you could say this bear in the data table is a small for its size or for its length bear. Sometimes these interpretations can be phrased differently. If I just want to know, is this bear's weight above or below the average length, or below, right? Predicted was 110 and we're at 85. I want to show you one more thing in StatCrunch. Let's go back to our data table, and let's say I want to calculate the regression. I'm just doing a new one because there's some options we didn't use before. So notice under the save, you can choose for StatCrunch to save predicted values, and make sure you hit Control to select a second, but you can also ask it to save residuals. Here's part of the issue though. StatCrunch is using more decimal places of accuracy than our MyMathLab might tell us to. So when we're looking at this bear, who's 149 centimeters, notice it gives us lots of decimals, but its predicted value is close to ours, and the residual is close. But on MyMathLab, you have to use the rounded value that it asks you for the regression line and carry it through. If you're using the unrounded model here, it's going to give you an error because it most likely does not know how to handle that difference in values. Sometimes there's built-in sort of error ranges, but sometimes these can be slightly outside of that. So just be aware here, but then also think about checking your answers by going back and looking at these predicted values. In real life, you might as well use StatCrunch to predict the values. Keep in mind they're just predictions, and it's using all of the decimal places when they calculated the regression. Alright, so let's go back And there's one more thing we want to do. Back to our eText, let's go to page 207. The final thing we'll do is wrap this up with number 10. So we want to compute the coefficient of determination and then interpret that value. So the coefficient of determination should be calculated for us when we did our linear regression. And notice here it is as r squared. And if I were to round this decimal to 2, just to make it easiest to interpret, I could think about it as 0.50. Make sure you're careful with that 5, rounding the 49 up to 50. But if I think about it as 0.50, you can interpret the r squared as a percent, 50%. So if I look at this, that 50% is telling me 50% of my predicted, or 50% of the variation that I see, so from the actual, from the predicted, is from the model, and the other 50% is from unexplained values. So this 50% is a little tricky in this case, but it's telling you half of the variation is due to unexplained, half is due to explained. So go back and make sure you're careful with the percentages here, that you're interpreting the correct way, but this can give you some insight into, in this case, why your predictions aren't always that great. 50% of the variation is due to unexplained factors, which is quite a bit. So those r-squared values can also be helpful as those get large or small to provide us a different type of interpretation than just the r.